August 23, 1943. 20,000 feet above the Dutch coast, where the North Sea's grey vastness met the war-scarred shores of occupied Europe, Oberleutnant Hans-Joachim Marseille's slender Focke-Wulf 190 banked lazily through broken cloud cover. His eyes, honed by 280 confirmed kills on the Eastern Front, spotted the approaching American formation with the casual disdain of a predator surveying livestock. There, lumbering among the sleek Spitfires, flew his target. A Republic P-47 Thunderbolt, its massive radial engine cowling gleaming in the morning light like the forehead of some ponderous beast. Marseille's lip curled. The Americans had sent a flying tank to do a fighter's job. He radioed his swarm in that clipped, confident German that had terrorized Russian airfields from Minsk to Stalingrad. Wir Kuhformige Amerikaner, wir fetten Kuh. 4 cow-shaped Americans, 4 fat cows. What Marseille couldn't see from his cockpit, what no German pilot could yet comprehend through the fog of war and the arrogance of early victories, was that this particular cow had been bred for something far more dangerous than milk. The Thunderbolt's pilot, Lieutenant Robert Johnson of the 56th Fighter Group, felt the weight of his aircraft in every control input, 7 tons of aluminum, steel, and raw American industrial might. 17,000 pounds packed into a fuselage so wide a man could stand inside the cowling. Yet as Marseille's Focke-Wulf dove with that characteristic whine of its BMW 801 engine as the tracers began their deadly arch toward the American formation, Johnson did something that would have been impossible in any other fighter of the day. He shoved the giant throttle forward to its emergency war power stop. And the world changed. The sound came first. A deep, resonant thunder that seemed to emanate from the earth itself, amplified through the 18 cylinders of the Pratt & Whitney R2800 double Wasp engine, turning a 13-foot Curtiss electric propeller. 2,400 horsepower, a number that existed purely in theory until that moment, suddenly transformed into kinetic fury. The massive turbo supercharger, spinning at 30,000 RPM behind the cockpit, screamed its own mechanical song. Compression, combustion, power unlike anything the European war had yet witnessed flooded through the driveshaft, and the fat cow, the flying tank, the aerial battleship that German pilots had nicknamed the Jug with sneering contempt, revealed its true nature. It didn't just accelerate, it pounced. Marseille's mockery died in his throat as the supposedly clumsy Thunderbolt performed a maneuver that defied every Luftwaffe training manual. In a single power-on spiral climb that should have been physically impossible for an aircraft of such heft, Johnson's P-47 reversed the pursuit geometry. The German ace, trained in the ballet of light, nimble fighters, found himself suddenly the pursued. And then came the guns. 8 M2 Browning 50 caliber machine guns, each firing 750 rounds per minute, synchronized through the electrical gun sight to converge 400 yards ahead. The combined weight of fire was staggering, 60 pounds of lead and copper-jacketed death per second. Marseille's wing, engineered for lightness and agility, never stood a chance. The first burst ripped through its stressed-skin duralumin structure as if it were papier-mâché. The Focke-Wulf rolled inverted, trailing black smoke and aviation fuel, its pilot's final thoughts, a confusion of engineering assumptions shattered by American excess. This moment, repeated in various forms across the skies of Europe between 1943 and 1945, marked a fundamental shift in aerial warfare. It represented the triumph of a philosophy that German designers, obsessed with weight reduction and theoretical aerodynamic purity, had dismissed as barbaric. The P-47 Thunderbolt was not elegant, it was not subtle, it was, in the purest sense of the word, overwhelming. And its story begins not in the crucible of combat, but in the drafting rooms of Farmingdale, Long Island, where a Georgian immigrant named Alexander Kartveli looked at the future of air combat and saw something his contemporaries missed. He saw that the next war would not be won by the lightest fighter, but by the one that could absorb punishment while delivering it in industrial quantities. He saw that horsepower, not wing loading, would determine the ultimate victor, and he built his vision from aluminum, steel, and a willingness to defy every conventional wisdom of interwar aviation design. The genesis of the Thunderbolt traced back to 1937, when the United States Army Air Corps issued a requirement for a high-altitude interceptor. The specifications seemed reasonable enough on paper. A single-engine fighter capable of 400 miles per hour at 20,000 feet, armed with 2 machine guns and a single cannon. Republic Aviation, successor to the Seversky Aircraft Company, had been experimenting with large radial engines mated to streamlined airframes. Kartveli, Republic's chief designer, looked at the requirement and saw something more ambitious. While other manufacturers pursued incremental improvements on existing designs, he began sketching an aircraft of almost ridiculous proportions. The wing area alone would exceed 300 square feet. The fuselage would stretch to more than 36 feet. Empty weight would approach 10,000 pounds, a figure that made Air Corps procurement officers blanch. The mock-ups drew laughter at right field. This wasn't a fighter, the old hands said. This was a scaled-down bomber. But Kartveli had his reasons, and they were rooted in the hard lessons of combat that hadn't yet occurred. He understood that air-cooled radial engines, despite their drag penalty, offered survival advantages over liquid-cooled inline engines. A single bullet through a coolant line could down a Spitfire or a Messerschmitt. A radial could lose multiple cylinders and keep flying. He also understood that the turbo supercharger, a complex and temperamental device that used exhaust gases to compress intake air, represented the future of high-altitude performance. The device was large and heavy, requiring extensive ducting that snaked around the cockpit and through the fuselage. Rather than treat this as a design limitation, Kartveli embraced it. The ducting added structural strength. The weight forward of the cockpit balanced the massive tail surfaces needed for stability. Every pound served multiple purposes. The prototype, designated XP-47, first flew on May 6, 1941. Test pilots reported mixed impressions. The aircraft was indeed heavy on the controls at low speed. Ground handling required deliberate, forceful inputs. Takeoff runs stretched longer than any contemporary fighter. But once airborne, once that giant turbo spooled up, and the big prop bit deep into the thin air above 15,000 feet, something magical happened. The Thunderbolt came alive. It could outdive any fighter in existence, its rugged structure laughing at speeds that would tear the wings from a Spitfire or Bf-109. The initial climb rate suffered, true, but the sustained climb at altitude was unmatched. And the armament, those 850 caliber machine guns clustered in the wings, created a pattern of fire so dense that pilots reported watching their tracers walk across enemy aircraft like a sewing machine stitching death through aluminum skin. The first production models reached England in early 1943, assigned to the 4th Fighter Group, the same unit that had flown Spitfires before America entered the war. The transition proved brutal. Pilots trained on nimble aircraft found themselves wrestling with the Jug's mass. The early models lacked range, carrying sufficient fuel for barely 3 hours of flight. The turbo supercharger proved delicate, prone to failures that could strand a pilot over occupied France. Ground crews, accustomed to the relative simplicity of Allison engines, faced a learning curve that seemed to ascend at 90 degrees. For a brief, critical period, the Thunderbolt's reputation teetered on the edge of failure. German interceptors found them easy targets during early bomber escort missions. The fat cow seemed ready for the slaughterhouse. Then came the improvements, and with them, the revelation. Republic's engineers, working with combat feedback, refined the design with methodical American persistence. The P-47D model introduced a bubble canopy that eliminated the dangerous blind spots of the Razorback design. Internal fuel capacity increased to 370 gallons. Underwing pylons could carry drop tanks extending range to 850 miles, enough to reach Berlin and return. The engine, originally rated at 2,000 horsepower, received water injection that allowed momentary bursts of 2,400 horsepower without detonation. The turbo system gained reliability through better materials and refined controls. Each modification added weight, yet each paradoxically improved performance. The Thunderbolt, as some wags called it, became more dangerous with every pound. The transformation became evident during the summer of 1943 as the 8th Air Force's bomber offensive escalated. On August 17th, during the notorious Schweinfurt raid that cost 60 B-17s, P-47's claimed 21 German fighters, while losing only 4 of their own. The ratio, while still bloody, marked improvement. More importantly, the Thunderbolts demonstrated a capability that would define their combat record. They could absorb damage that would obliterate any other fighter and keep flying. Ground fire, cannon shells, mid-air collisions, the Jug took them all. Pilots returned with cylinder heads shot away, with gaping holes in wings large enough for a man to crawl through, with tail surfaces shredded to lace. One pilot, Lieutenant James Moorhead, landed his Thunderbolt after a mission over Italy with 153 separate holes in his aircraft. The ground crew counted them. Another, Captain Robert Rowland, flew home from a bomber escort mission over Germany with a 3-foot section of his right wing completely missing, sheared off by the blast from a flak burst. The Thunderbolt didn't just fly, it endured. This durability translated into a psychological advantage that no performance chart could capture. German pilots, trained to respect the mathematical precision of energy management and angular combat, found themselves facing an opponent that defied their textbooks. You could hit a P-47 with a full deflection burst from a 109's cannon, see the strikes, watch the pieces fly off, and the damned thing would keep coming. It would keep coming with 8 guns blazing, with more ammunition than any German fighter carried, with a closing speed that made disengagement a dangerous gamble. The fat cow had become the boar of the air, a creature that seemed to grow more enraged with every wound. The numbers began to tell a story that German intelligence couldn't ignore. By the end of 1943, the 56th Fighter Group alone had destroyed 233 enemy aircraft in aerial combat. The group, nicknamed Zemke's Wolfpack after its aggressive commander Hub Zemke, flew exclusively Thunderbolts. Their kill ratio improved monthly. In January 1944, during a single engagement over the Pas de Calais, 12 P-47's engaged 40 German fighters. The Germans lost 16 aircraft, the Americans lost none. Oberst Johannes Steinhoff, commander of Jagdgeschwader 77, reported to Luftwaffe High Command that the Thunderbolt had become the most dangerous opponent his pilots faced. The memo was classified. It was also ignored by a high command still enamored with the myth of German technical superiority. The strategic implications extended beyond mere kill ratios. The P-47's range extension in early 1944 allowed it to escort bombers deep into Germany, fulfilling the promise of the 8th Air Force's daylight bombing strategy. Where Spitfires had to turn back at the German border, where early P-38s struggled with engine reliability in the cold European winter, the Jug pressed on. Its turbo-supercharger, that heavy, complex system that added nearly a ton to the aircraft's weight, allowed it to maintain full power at 30,000 feet. German fighters, even the advanced Focke-Wulf 190, suffered power degradation above 25,000 feet. The Thunderbolt thrived in the thin air. It could pace the bomber streams at their cruising altitude, and when the Luftwaffe rose to intercept, it could outdive them to the attack, recover from speeds that would tear lesser aircraft apart, and climb back to altitude for another pass. The aerial battles over the Reich during the first half of 1944 became the Thunderbolt's proving ground and its apotheosis. On March 6th, during a massive raid on Berlin, P-47's claimed 62 German fighters against losses of 11. A week later, on March 18th, they destroyed 74 more. The Luftwaffe's carefully husbanded reserves of experienced pilots evaporated. Each mission, the Americans seemed to field more Thunderbolts, each pilot growing more confident in his massive machine. The Germans, constrained by fuel shortages and production limitations, could not match the attrition. Their pilots flew until they died, facing an opponent that seemed to embody American industrial capacity itself. Big, tough, and endlessly renewable. The technical details that created this superiority deserve examination, for they reveal the fundamental difference between American and German design philosophy. The Pratt & Whitney R2800 double wasp engine displaced 2,800 cubic inches. Its 18 cylinders arranged in 2 rows, air-cooled by a massive cowl flap system that could modulate cooling airflow. The engine alone weighed more than an entire Messerschmitt 109 fuselage. But weight, in this case, brought reliability. The radial design meant no vulnerable coolant system. The large displacement meant conservative operating stresses. German engines, refined to the edge of theoretical limits, produced impressive specific power but required frequent overhauls and suffered catastrophic failures when pushed beyond design parameters. The Double Wasp, in contrast, could operate at combat power for hundreds of hours between major overhauls. It was the difference between a racing engine and a truck engine. The racing engine won qualifying laps. The truck engine won wars. The turbo supercharger system represented the Thunderbolt's true technical masterpiece. Exhaust gases spun a turbine at 30,000 revolutions per minute, which drove a compressor that forced air into the engine at pressures up to 3 atmospheres. This allowed the R2800 to produce its rated power at 30,000 feet, where naturally aspirated engines wheezed at half their sea-level output. The system added complexity, weight, and cost. It required precision manufacturing and careful maintenance, but it gave American pilots a performance envelope that German designers, committed to simpler mechanical superchargers, couldn't match. The ducting that carried compressed air from the turbo, mounted behind the cockpit, to the engine at the nose ran along both sides of the fuselage. These ducts, nearly a foot in diameter, added structural rigidity. They also absorbed battle damage, acting as armored corridors that protected the pilot and critical systems. Cartvelli's floor had become a feature. The armament package, those 850 caliber Brownings, reflected American faith in volume of fire over precision. Each gun fired a bullet weighing just over an ounce at 2,900 feet per second. The combined rate of fire sent nearly 100 rounds downrange every second. German fighters typically carried 2 or 3 cannons supplemented by 2 machine guns. The cannon fired heavier shells but at slower rates and with less ammunition. In the fleeting seconds of a high-speed deflection shot, the Thunderbolt pilot could afford to hose his fire across the target, walking the tracers into the enemy aircraft. The German had to aim with surgical precision, a near impossibility against the Duke's robust structure. The mathematics of lethality favored the American approach. A 1-second burst from a P-47 struck its target with approximately 650 pounds of kinetic energy. Nothing in the air could absorb that punishment and survive. The human element of the Thunderbolt story reveals as much about American society as it does about aviation technology. The pilots who mastered the jug came from a generation raised during the Great Depression, young men who had learned to coax performance from tired automobiles and temperamental farm machinery. They approached the Thunderbolt not with the horror of its size, but with the appreciation of its potential. Where British pilots saw a clumsy beast, Americans saw a powerful tool. The training reflected this. American flight schools emphasized instrument flying, systems management, and teamwork. German training, superb in its early years, focused on individual aerobatic excellence. The war's attrition degraded German instructional quality while American training improved. By 1944, the average P-47 pilot had 300 hours in type before his first combat mission. His German counterpart might have 50 hours in the Bf-109 or Fu-190 he would fly to his death. The ground crews who maintained the Thunderbolt represented another American advantage. Republic designed the aircraft with maintainability in mind, despite its complexity. Engine changes, a nightmare on some contemporary designs, could be accomplished in 4 hours by a trained crew. The turbo system, though intricate, used modular components that could be swapped in the field. American logistics ensured that spare parts flowed forward in an unending stream. A Thunderbolt squadron in England could count on daily deliveries of engines, propellers, guns, and electronics. German units scavenged wrecks for parts, improvised repairs with whatever materials they could find, and watched their serviceability rates drop below 50%. The fat cow required more feed, but the feed was always available. The tactical evolution of Thunderbolt employment reveals how military organizations adapt to technological capability. Initially used as a traditional escort fighter, flying close to bomber formations, P-47's suffered from the same limitations as their lighter brethren. They reacted to German attacks rather than preventing them. Hub Zemke and his contemporaries realized the Thunderbolt's true potential lay in offensive sweeps, roaming ahead of the bomber streams to intercept German formations before they could attack. The Jug's range and durability made it the perfect aircraft for this role. It could fight its way into German airspace, engage at will, and fight its way out. The big engine and turbo meant it could dictate engagement terms, declining combat when disadvantageous and initiating when favorable. German pilots, flying aircraft optimized for point defense, found themselves constantly reacting to American initiatives. The psychological burden shifted. Now the German was the prey, stalked by a predator that could choose its moment. The statistical record of the Thunderbolt's combat career borders on the unbelievable, yet the documentation is irrefutable. In the European theatre alone, P-47's flew more than 500,000 sorties. They destroyed 3,752 enemy aircraft in aerial combat, a figure that climbs to more than 4,000 when including Pacific operations. They delivered more than 130,000 tons of bombs in ground attack missions, a greater tonnage than many dedicated light bombers. They destroyed thousands of locomotives, tens of thousands of motor vehicles, and countless artillery pieces. Of the 15 highest-scoring American fighter groups in Europe, 7 flew exclusively Thunderbolts. The 56th Fighter Group, Zemke's Wolfpack, became the top-scoring group with 667 aerial victories. Their loss rate was the lowest among 8th Air Force fighter units. The Fat Cow had become the most efficient killer in the American arsenal. Individual aces in Thunderbolts achieved scores that rivaled German totals. Despite flying in an environment where opportunities for individual glory had given way to industrial-scale warfare, Major Robert Johnson, the pilot who had faced Marseille in that formative engagement, finished the war with 27 confirmed kills, all in P-47's. His memoir, Thunderbolt, describes the aircraft with the affection of a man describing a trusted friend. He wrote of returning from missions with his aircraft so shot up that ground crews assumed he had flown through a hailstorm. He described the unique sound of the turbo supercharger spooling up, a high-pitched whine that signaled deliverance from danger. He recounted watching German cannon shells explode against the Thunderbolt's armor plate, feeling the impacts shudder through the airframe, and knowing that his lighter opponents could not survive similar punishment. His account of the engagement with Marseille, though the German ace died in North Africa before they could have met that August day, captures the essence of the Thunderbolt myth. The aircraft created a psychological space where American pilots felt invulnerable and German pilots felt helpless. The German perspective, preserved in captured documents and post-war interviews, reveals a grudging respect that evolved into something approaching dread. Luftwaffe pilots initially dismissed the Thunderbolt as a simple target. By late 1943, they recognized it as a dangerous opponent, particularly in dives. By 1944, they feared it. The fighter ace Gunther Rahl, who scored 275 victories against Russian and Western opponents, described the P-47 as the most difficult opponent in the West. He noted that its diving capability made the classic defensive split S maneuver suicidal. A German pilot diving away from a Thunderbolt often found the Americans staying with him, guns blazing, while the Germans' own aircraft began to shed wings or control surfaces from excessive speed. The choice became stark: stay and fight at a disadvantage, or dive and die. Many chose a third option, breaking off combat entirely when Thunderbolts appeared, preserving themselves for easier targets. This had strategic consequences. German fighter units, unable to effectively intercept bomber streams heavily escorted by P-47's, allowed increasing numbers of American bombers to strike targets with precision. The Luftwaffe's defensive attrition accelerated. Its experienced pilots died. Its training pipeline collapsed. The Thunderbolt, more than any other single aircraft, broke the back of the German fighter arm. The Pacific Theater provided a different but equally compelling validation of the Thunderbolt's design philosophy. Operating in an environment where range and durability were paramount, the P-47 proved ideally suited to the long overwater flights and primitive forward bases that characterized the war against Japan. The 7th Air Force's Thunderbolts, operating from island bases, ranged hundreds of miles to strike Japanese positions. They absorbed the corrosive effects of salt spray, tropical humidity, and abrasive coral dust that grounded more delicate aircraft. Their air-cooled engines laughed off the small-caliber machine gun fire that often plagued ground attack missions, and when they encountered Japanese fighters, the outcome repeated the European pattern. The agile but fragile Zero and Oscar fighters could turn inside the jug, but one pass from those 850 calibers usually ended the engagement. Japanese pilots, like their German counterparts, learned to avoid the Thunderbolt when possible. When avoidance failed, they died. The final chapter of the Thunderbolt's war saw it evolving into a role its designers had never fully envisioned. With the invasion of Europe looming in mid-1944, P-47 squadrons began intensive ground attack training. The same characteristics that made them superior air-to-air fighters translated perfectly to the close air support mission. The armor that protected pilots from German cannon fire also protected them from ground fire. The massive payload capacity allowed Thunderbolts to carry 5-inch high-velocity rockets, a weapon system that proved devastating against armored vehicles. The air-cooled engine tolerated the dust and debris of operating from forward landing strips. The Thunderbolt became the Allies' aerial artillery, roaming the battlefield in flights of 4 or 8, destroying anything that moved. During the breakout from Normandy, P-47's flew more than 10,000 sorties in 3 weeks. They destroyed bridges, disrupted supply lines, and created such havoc behind German lines that German troops came to fear the distinctive sound of the big radial engine more than any other aspect of Allied air power. The fat cow had become the angel of death to an army. The production numbers tell a story of American industrial mobilization that dwarfed German efforts. Republic Aviation, working from a purpose-built factory in Evansville, Indiana, produced more than 15,000 Thunderbolts between 1941 and 1945. At peak production, a completed P-47 rolled off the assembly line every 2 hours. Ford's Willow Run plant, famous for B-24 production, manufactured subassemblies. Continental Motors built the engine mounts. Hamilton Standard built the propellers. The complexity of the supply chain, spanning thousands of miles and hundreds of subcontractors, functioned with a precision that seemed miraculous. German production, by contrast, remained handicapped by shortages of strategic materials, by Allied bombing of component factories, and by a refusal to standardize designs. The Luftwaffe fielded dozens of fighter variants, each requiring unique parts and specialized maintenance. The Americans built one basic Thunderbolt design, refined it methodically, and produced it in staggering numbers. Quantity, as Stalin allegedly observed, has a quality all its own. The Thunderbolt proved the point. Post-war analysis by both American and German aviation experts reached conclusions that validated Kartvelli's unorthodox approach. Wind tunnel testing confirmed that the Thunderbolt's large wing, despite its weight penalty at low altitude, provided excellent high-altitude lift and maneuverability. The big fuselage, mocked as a barn door, actually produced less drag at combat speeds than the slimmer profiles of contemporary designs. The turbo supercharger system, though heavy, provided a specific fuel consumption advantage at altitude that translated into superior range and endurance. The armament package, considered excessive by pre-war standards, proved perfectly calibrated for the realities of high-speed deflection shooting. Every flaw that German engineers had identified in the Thunderbolt's design turned out to be a strength when viewed through the lens of actual combat conditions rather than theoretical performance charts. The fat cow had been lean in all the right places. The human cost of the Thunderbolt's success remains difficult to quantify precisely, but the outlines are clear. American P-47 units suffered approximately 2,000 combat deaths in the European theatre. German losses to Thunderbolts ran into the tens of thousands when counting both aircrew and ground personnel killed in strafing attacks. The aircraft's durability undoubtedly saved hundreds of American lives, pilots who would have died in less robust machines. Yet the Thunderbolt also enabled the strategic bombing campaign that killed hundreds of thousands of German civilians. The ability to escort bombers to Berlin meant that American air power could strike at the heart of German industry and infrastructure. The moral calculus of this destruction extends beyond technical analysis into questions of total war and the boundaries of acceptable violence. The Thunderbolt, for all its engineering excellence, was an instrument of industrial-scale killing. It performed its role with brutal efficiency. The legacy of the P-47 extends far beyond its combat record. Its design philosophy, that bigger could indeed be better when properly executed, influenced post-war fighter development. The jet age, with its thirst for fuel and reliance on powerful engines, embraced the Thunderbolt's lessons. The F-86 Sabre, America's first great jet fighter, inherited the P-47's emphasis on durability and firepower. The F-105 Thunderchief, designed by the same Republic aviation team, explicitly sought to create a jet-powered Thunderbolt for the nuclear age. Even the Aten Thunderbolt II, the modern ground attack aircraft, carries the name in deliberate homage to its World War II predecessor, sharing its design philosophy of survivability and overwhelming firepower. The Fat Cow had become the patriarch of a warrior dynasty. In the end, the story of the P-47 Thunderbolt is not merely a tale of aircraft design or aerial combat. It is a parable about assumptions and realities, about the danger of judging capabilities by appearance rather than performance. The German pilots who laughed at the jug's bulk paid for their mockery with their lives. The American pilots who mastered its mass gained a weapon that protected them and destroyed their enemies. Alexander Kartveli, the Georgian immigrant who dreamed in aluminum and drew in dimensions that seemed absurd, created not just a fighter, but a symbol. He proved that American industrial might, applied with intelligence and courage, could overcome the most refined theoretical designs of an enemy fighting for its existence. He proved that sometimes the best solution to a problem is simply to make it bigger, stronger, and more powerful than anyone believed possible. 70 years after the last Thunderbolt rolled off the assembly line, the aircraft still flies in the hands of civilian warbird operators. At airshows across America, the big radial engine's thunder still shakes the ground. Children point at the massive shape and ask their parents if such a thing could really fly. Veterans of the war, now in their 90s, watch with tears in their eyes, remembering what it felt like to sit behind that huge engine, to feel the turbo spool up, to know that they rode in something invincible. The Fat Cow, they know, was never a cow at all. It was a dragon, disguised in aluminum, breathing fire through 8 machine guns, and it had saved their lives. The German pilots who laughed had not lived long enough to understand what they faced. Those who survived the war understood all too well. In the final analysis, the P-47 Thunderbolt taught the world a lesson it keeps forgetting and relearning. In war, as in life, the deadliest opponent is rarely the one you expect. It is the one you underestimate,